So hi everyone, look at this question. First of all, read the question carefully before solving. An amount of ice having mass 10 to the power minus 3 kg and temperature of ice is minus 10 degrees Celsius is transformed to vapor of temperature 110 degrees Celsius by applying heat. Actually, they are asking not total amount of what, total amount of heat required for this conversion. Okay, so specific heat of ice is given, water is given, every data is given. Now we will understand we are having a ice. This ice cube like this. The temperature of ice is minus 10 degrees Celsius. So once you provide heat, then ice will change its temperature to 0 degrees Celsius. Then after that you are providing heating, but there is no increase in temperature. So phase is going to change. After this, you are increasing the temperature up to 100. After this, from 100 to 100 and again 100 will be here because phase is going to change. Then 100 to finally 110 degrees Celsius. So I will write also minus 10 here, solid ice, solid, solid. Here entire solid is going to convert into liquid when we supply some heat that change the phase. Okay. Again here like liquid, entire liquid is converted to vapor. Here also vapor. So simply like here amount of heat, let us suppose Q1 we are going to provide in the next Q2. If you want to write delta Q1, delta Q2 here, here delta Q3, here delta Q4, here delta Q5. Clear? So delta Q1 you can easily solve simply M specific heat delta theta. So mass of ice is 10 to the power minus 3. Specific heat capacity of ice, how much? 2100 joule per kg per Kelvin. How much increase in temperature? 0 to, you know very well, 0 plus you will write in Kelvin like 273. Okay, you are writing, you will write like this. Okay, minus 10 to 0. So you will convert minus 10 plus 273 if you write. Now, why am I writing in Kelvin? I will tell. I just want to show you. Even if you write in Kelvin, this is 10 to the power minus 3 kg, 2100 joule kg per Kelvin. You will observe that 273 is cancel out. So even you write in degree Celsius or degree Kelvin, change will remain same. Okay. So it is 10 Kelvin, Kelvin cancel, kg cancel. So how much you are getting like 2100 multiply 10 to the power minus 3. Just solve it, you will get 21 joule. So delta Q1 comes out to be 21 joule. In the similar way, you can easily solve delta Q2. Now in delta Q2, phase is going to change from solid to liquid. So how much heat is required? Mass into latent heat of what? Fusion. So mass of how much mass? Whatever mass is here, same mass is here. The entire solid is going to convert into liquid. So mass will be 10 to the power minus 3 into latent heat of how much? Just check. Latent heat of ice is given 3.35 into 10 to the power 5 joule per kg. So please solve. You will get 335 joule. Understood? Delta Q2. Similarly, delta Q3 will solve. Again M as delta T. How much mass is given 10 to the power minus 3 kg? Specific heat. See here liquid, specific heat capacity of water. 4180. How much change in temperature? 100 minus 0. So finally you will get how much? 418 joule. Clear? So we are providing heat. That's why all the answer will be positive. You can check delta Q1 is positive, delta Q2 is positive, delta Q3 is positive. It means that we are providing heat to the system. Okay. In a similar way, delta Q4 you will calculate. There is no change in temperature. You can check 100, 100. So M into L. Simply M is how much? 10 to the power minus 3. L is how much? Uh, Latent heat of steam. You can check. Latent heat of steam is 2.25 multiplied 10 to the power 6. Clear? So how much will be 3 3 cancel 2250. Delta Q4 comes out to be 2250. Is it okay? So delta Q1 you got delta Q2, delta Q3, delta Q4, now delta Q5. How will you solve delta Q5? Just see delta Q5. Delta Q5 will be mCp or ms delta T. So mass is 10 to the power minus 3 kg. Now specific heat. See here it is vapor. Here it is vapor. Now vapor temperature is going to change from 100 to 110. So we will put specific heat capacity of steam 1920 joule per Kelvin. Okay, 1920 joule per kg per Kelvin. Is it clear? 100 to 110 means how much? 10 Kelvin. Kelvin, kg cancel. So it comes out to be 1 it is cancel out 19.2 joule. Clear? Delta Q5. You check all the calculation and check the answer 19 point. So total heat they are asking now. Simply add. This question is easy actually, but little bit lengthy. Okay. Delta Q1 plus delta Q2 plus delta Q3 plus delta Q4 plus delta Q5. So once you add all the heat like delta Q1, delta Q2, all the heat you will get 3043.2 joule. I hope this doubt is clear. For any doubt, assistance, you can contact me anytime like you can message. I'm always ready. Thank you so much. Thanks a lot.